In this video, as requested, we're going to derive a line versus phase voltage. So a line voltage and these voltage measures across these nodes. Could be line, oh sorry, it could be line AB, it could be line BC, it could be line BC. So we can have three line voltage ES voltages here, and phase voltages are these ones. So I think it is worth noting that I could phase voltage, let me say, let me do line voltage diagram, phasor diagram. Here we have VA. Now can it be like that? Yeah, let me just have VA here. Then here I'll have VB here. Here I have VC. So all of them here are 118. I'm 120. Why am I 120 degrees out of phase? So oh yeah, okay, cool. So we can build out of that. What else we know that we can say that? Let me see what else we can use as our advantage. We could notice that all the VNs are of the same magnitude here. All of them are of the same magnitude. So yeah, I could just note that one down. I could say all the V phases are of same magnitude. I'm talking about VNA is the same as VNB. I can also talk about it's equals to VNB, then that is VNC. They all have same magnitude, but they are all out of phase, right? Out of phase with an angle of 120. I think that you can see here they're all out of phase. So with that being said, we can be able to compute VAB, of which what is VAB exactly? It's a line voltage. Okay, we're trying to get the relationship between a line and a phasor voltage. Is going to equals to, let's say, VNA, but this is like this way, so it's going to, we see the plus at the side, minus the side, plus the side, so they have different sign. Minus VNB, so I could say VA pieces AB is equals to VN VNA. I'm just copying here, I don't know why I'm having problem. Minus VNB is here, V open, I mean not open, angle negative 120 degrees, close. I'm just recording what is just here. We also know VN, it's also angle V, I mean magnitude V and angle of nothing. So what else can I say? So from here, I think I can just take out, for easy of things, I could just take out a common factor. Just remove that bracket because I didn't see a need for it. I could just take out a common factor V, and then after I'll have 1 angle naught minus 1 angle 120 degrees, close, and then my V will still gonna be outside, but I'll have to change this to a polar form. And hope I didn't do any mistake. If you don't know how to change this, I did show how to do it with the calculator on the other videos. Please check that out. So you're going to get 3 minus root 2 all over 2, and then there'll be a complex part. Then I could change it back to polar. If I change it back to polar, let me just do it with my calculator again. You could do it with your head if you can, but I prefer just do it. Now I'll have my V here open. Here I'll have root 3 negative 18, close. Then I'll just have root 3v negative 30. That is going to be my VAB, of which VAB is it's a V line. So this is your answer, and this is your relationship between phasor and line voltages. So this only if this is a derivation for Y connection of 3-phase. I can call it Y, or some people on other book they call it star connection. So they call star or Y circuits. So look at where we started with deriving line voltage versus phasor voltage. We notice that all the magnitude are the same. We said that here, and then but they're just out of phase by 120. Then if that is the case, if I want a voltage here, I'll have to do what? I'll have to get this voltage minus this one, because I'm trying to get them moving this direction. So that's why I'm negating that one. Then I end up with something like this, and then I change it back to here. Remember, this was only for VAB. If you want for other V's, just remember they're still 120 out of phase. You're just changing the phase here. Keep on adding or subtracting 120 depending on which direction that you want to go. Also, I think I need to add that when you're working with this problem, you need to consider, let me talk about mostly Y, and I think that one is delta. I'm using delta, delta connection. The only thing to remember is that if you're working with Y, you are more working like series. So if it's series, yes, voltage divide, and then current is the same. So for if you want a relation, V line is going to be root 3 of V phasor. I think that's what we just proved. And current line is going to be the same. Current line is going to be the same as current phasor. So I think these are things that you need to remember if you're working with what? Working with the star or Y connection, 3-phase connection. So I think it's also balanced, because all the resistors are assumed they're the same, or whatever that is in there on the star is all the same. And for a delta connection, these things are just literally opposite, or should I say they're conjugate, because they just change the other way around. So if it was divide, multiply, equal, this will go. So please, thank you, please subscribe and share. Thank you for watching, and don't forget to share with your classmates.